in the generalized sense of this well-established and widely used terminological expression. Drilling different purpose wells helps solve a significant range of production and theoretical issues related to the need to search for promising structures for the available useful components and study the specific geological and technical conditions of stratified mineral deposits, with further creation of powerful industrial complexes for their effective extraction and partial local processing. The considered combined drilling method was studied rather comprehensively by means of analytical and bench modeling. The following can be noted among its main results. The method is characterized by active development of breaking deformations in the form of cracks and holes. The method is characterized by a clear dependence of the scale of breaking processes on the application of axial load and its subsequent physical results, compared to cases of rock breaking in the absence of dynamism of axial load application. This is illustrated both qualitatively and quantitatively on the corresponding graphs in Figure 1 and Figure 2. Slide 3 demonstrates a general scheme of the proposed hydraulic hammer. The installation operations with the lower adapter 12 are convenient, as there is the recess 31 for the drilling sickle-shaped tongs on its surface. The principle of hydraulic hammer operation in the automatic mode and possible adjustment of the latter are based on the creation of a regular periodic flushing fluid circulation for the hydraulic hammer, which can be achieved by operational transformation of the drilling pump design. A combination of the technological scheme of operation and interaction of plungers, disconnection of a compensator, and modernization of the piston operation cycle. Special experimental studies were conducted at the Department of Oil and Gas Engineering and Drilling of Dnipro University of Technology. Their purpose was to clarify the patterns of influence of surface active substances, surfactants, and polymer additives on hydraulic supports during the movement of liquid through a pipeline. These studies were performed on a special stand, slide 4, where pressure drop delta R was measured in a standard steel pipe with a diameter of 14 mm and a length of L equals 4.5 meters, through which the NB11E pump pumped the studied liquids at different speeds. They were controlled with the help of a valve, marked as B in the diagram, slide 4. DT10 pressure sensors, marked as M1 and M2 in the diagram, slide 4, VT21 equipment complex, and an oscilloscope were used to measure pressure and determine its difference for the solutions and without surfactants and polymer additives at the tube inlet and outlet. While analyzing the data represented in slide 5, following conclusions can be drawn. Polymer additives and surfactants within a certain range of concentrations reduce hydraulic resistance, but the degree of this effect depends on the polymer and surfactant types. The greatest reduction of hydraulic resistances can be obtained with the use of polyacrylamide and polyoxyethylene additives. Moreover, it was found that plant polymers lose their effectiveness during the circulation through a pipeline as a result of so-called destruction of molecules, which is evidenced by a decrease in the solution viscosity. To maintain the duration of the effect of hydraulic resistance reduction, it is necessary to use polymers in combination with additives of special reagents stabilizers. In general, the task of planning an effective hydraulic washing program means development of compositions and technology for preparing such washing liquids, which would have simultaneously the following most important properties: reducing the coefficient of internal friction, thereby reducing hydraulic resistance, decreasing the surface tension, reducing the manifestation of friction effect during the rotation and contact of a drill string and a rock breaking tool with the rock due to lubrication, and preventing swelling, wetting, and falling of clayey and other unstable rocks. Basing on the analysis of the experimental data shown in slide 6, it can be stated reasonably that, of all the considered substances, the greatest reduction in the friction coefficient can be obtained when tall oil is added into the drilling fluid. According to the complex experimental data shown in slide 7, following conclusions can be made. When processing washing liquids, in this case, technical water, with the studied surfactants, a decrease, sometimes quite significant, in surface tension sigma by 10 to 240% is observed, and such a transformation of sigma indicator is noted in the concentration range of 0.5 to 1% surfactant. Use of flushing fluids with a reduced sigma index during the rock mass breaking results in the increasing maximum possible mechanical speed of drilling by the basic 1.6 times for percussive rotary drilling and by 1.3 times for the rotary method of well construction. Thank you.